The Multiple Applications Table, patented by Excellence in Rehabilitation Company, has requested our expertise to conceptualize a rehabilitation apparatus tailored for the diverse needs of physical therapists, enabling them to deliver a comprehensive spectrum of treatment and care through a singular device. The proposed product solution involves the development of a versatile table capable of functioning as a treatment table, traction table, gravity-resistant lower extremity exercise platform, mounted pulley exercise table, and a tilt/inversion table. The mat table must be able to lift and lower from 19 to 33 inches, tilt between -8 and 38 degrees from a level plane, and function with a patient weighing 500 pounds with minimal deflection. Excellence in Rehabilitation has also requested the redesign of the braking mechanism that secures the top rolling portion to the top frame. The new and redesigned mat table integrates the capability of lifting and lowering the level table within the range of 19 to 35 inches from the ground and can tilt between -10 and 39 degrees from a horizontal position. The redesigned mat table also has a 500-pound lifting capacity to accommodate a wide range of patients, meeting the requirements of Excellence in Rehabilitation. To obtain the lifting and tilting requirements, two 10-inch, 8,000 Newton high-strength linear actuators combined with thoroughly engineered steel lifting members provide the means to meet the specifications set forth by Excellence in Rehabilitation. All steel members are 1-inch by 2-inch, low-carbon steel rectangular tubing with a wall thickness of 1/8 inch to provide adequate strength, especially when a heavy patient utilizes the mat table. The base frame is the foundation the other parts are built from. Members are strategically placed in locations to provide the optimal mounting locations. Heavy-duty rail and carriage assemblies are mounted to the base frame to provide the needed movement of the lifting mechanism that lifts the head portion of the table. The modified scissor lift mechanism is composed of an H-post design and a field goal post design. A standard scissor lift mechanism would not work with this design since the table needs to have the tilting ability. There would be interference during tilting if a standard scissor lift mechanism was designed. The linear actuator pushes against the head H-post, which moves the field goal post. Rotation at the connection points between the head H-post and field goal results from the field goal being constrained to only one linear axis of movement by the rail and carriage. The foot end H-post is secured to the base of the table with fasteners that allow only rotation. The foot end H-post uses rollers to secure to the top frame to allow the needed motion when being pushed or pulled by the actuator. The linear actuator is connected in the middle of the H-post to provide the needed motion to achieve the lifting and tilting capability. The top frame of the table is designed to be the same overall size as the previous mat table prototypes to accept the unchanged components during this prototype's design. The accessories that are fixed to the tabletop surface are out of the project scopes. Therefore, the model will utilize the design from previous prototypes. The top cushions and accessories will fit on the top frame without additional modifications. Slots are machined in the lower portion of the top frame to accept the inner HDPE rollers, and the slotted members are left open at the end to allow maintenance and assembly of the roller system. Shoulder bolts, thrust bearings, and nylon spacers are used at each connection point. The shoulder bolts were used since they are designed to work in areas where rotation occurs. Thrust bearings were used to allow tightening of the connection points without hindering the rotation. The next improvement for the redesigned mat table was the handbrake that is utilized by the physical therapist. The old handbrake, which secures the top roller assembly to the top frame, was originally designed to be a pin and hold system actuated by a plunger system. The previous handbrake was cumbersome to operate and did not provide the needed securement. In other words, the plunger system was challenging to use by the physical therapist since it is challenging to determine if the brake is on, and there was also excess movement in the top frame when the pin was deployed in the hole. The main reason there was movement or play was from the difference in hole size compared to the pin diameter. The pin was determined to be 1/8 inch smaller than the hole, resulting in unwanted movement when secured. This issue was addressed by integrating a toggle clamp into design. The toggle clamp provides a visual means to determine whether the handbrake is on or off, depending on its orientation, and increases the ease of operating. In the new design, a pin and hole system was still used as it provides proper securement, but was improved from the past design. The holes along the top frame were drilled undersized, and the pin that is secured within the toggle clamp is tapered. This allows the mechanism to create an interference fit when locked. This eliminates the movement of the braking system. One of the biggest obstacles overcome was designing the optimal mounting locations for the linear actuators to obtain the required lifting and tilting specifications. Linear actuators, specifically linear actuators that have a high strength, have a much longer retracted length than its extended length or stroke length. The retracted length of a linear actuator can be up to 1.5 times longer than the stroke length of the actuator due to the size of the motor required for the heavy lifting ability. This makes it challenging to fit in tight spaces that require specific stroke lengths. Many hours were spent choosing the optimal mounting locations for the actuators. There is really nothing on the market that incorporates lifting and tilting to the extent that the newly designed mat table can accomplish. The lifting and tilting mechanism had to be designed from the ground up to meet the specifications. Key features that allow the mat table to function as desired include the modified scissor lift mechanism and rolling wheels that are secured in the slotted top frame member. SolidWorks was heavily used in the early design phase of the project to determine optimal lengths and orientations of the lifting and tilting mechanism and the actuator mounting locations. SolidWorks was also used for the strength and deflection analysis using its internal FEA software. Excel was utilized to solve complex equations to obtain the forces on each connection point of the table. An adaptive Excel sheet allows the designer to determine the reaction forces at any point of the table with differing loads and position of the loads. This helped choose orientation of actuators, size of actuators needed, and the fasteners used. This project utilized a simple plug-and-play system, a control box connected to the linear actuators, and controller to provide user input. For this prototype of the mat table, there was no programming done since the actuators used for this prototype do not have feedback control. The mat table that will be used for production will incorporate actuators with positional feedback control to program and provide physical therapists with smooth and easy operation. Linear actuators with positional feedback control will help smooth the motion of the table and will allow the speed of each actuator to be increased or decreased so that they can work together in tandem. The redesigned mat table accepts input from the physical therapist. Once the patient is lying down on the table, the physical therapist can adjust the height or tilting angle of the table. Here, the physical therapist is increasing the height of the table from 21 inches to 35 inches by extending both the foot and head end linear actuators. To move the patient into a negative angle, the physical therapist retracts the head end linear actuator. The mat table will reach -10 degrees at its maximum negative angle. Now, the physical therapist can then extend the head end linear actuator and slowly retract the foot end linear actuator to obtain the maximum possible angle of 39 degrees. At any point, the physical therapist can stop the actuator to complete the desired exercise.